So let's continue our discussion on solving inequalities. Here we've got another inequality that we're asked to solve for. First thing we do is we get x to one side. So we're going to move this x over to the other side. So it gives me 2x plus 7 is greater than or equal to negative 3. Then we move the constants to the other side. So it gives me 2x is greater than negative 10. Now up until this point, all I've done was subtract terms to the other side. Subtracting is okay. We do not need to change inequality symbols when we subtract. Now we divide out the coefficient. I am dividing by a positive number. Dividing by a positive number is an okay operation. We do not need to change the inequality symbol. So this is my inequality solution. I will also show you the graphical solution and the interval notation solution. The graphical solution is on a number line, and I want to show any number that is greater than or equal to negative 5. So any number greater than or equal to negative 5 would be shaded everywhere to the right. I will include negative 5 since it has the underscore. The interval notation is really easy once you have the graph. It starts at negative 5 and goes all the way to infinity. Negative 5 is included. Infinity is never included. So there are 3 different solutions, all saying the same answer. Part C. Anytime you have fractions, if you recall back to your instructions from equations back in chapter 1.1, we talked about how to get rid of fractions. Anytime you have an equation or an inequality with fractions, your best way to get rid of them is to multiply both sides of the equation by some number that will eliminate all the denominators. In this case, the common denominator would be 12. So I'm going to multiply both sides of the equation by 12. When I do that, I have to distribute. So 12 times this first fraction plus 12 times this other number is less than 12 times this next fraction. So you'll see that the 12 and the 6 will reduce, the 12 and the 12 will reduce. So my denominators are now gone. So all I'm left with is 2 times 4x minus 3 plus 24 is less than 2x minus 1. Now I have no fractions. So let's finish solving. Let's distribute the 2. So I have 8x minus 6 plus 24 is less than 2x minus 1. Combine like terms. 8x plus 18 is less than 2x minus 1. I'm going to move the 2x to this side. That gives me 6x. At the same time, I'm going to move the 18 over to this side. So I have 6x is less than negative 19. Then we're going to divide out the coefficient. So that gives me x is less than negative 19.6. I never multiplied or divided by a negative number, so I never had to change the sign. So here's my inequality. The graphical solution, negative 19.6 is between the integers of negative 3 and negative 4. So negative 19.6 is in between those two numbers, and x is less than that number. So right about here is where you're going to find negative 19.6. And I want to show that x is less than that number. So I would shade everything to the left. In interval notation, we start with the smallest number on the left, which is negative infinity. And it goes up to the biggest number on the right, which in this case is negative 19.6. So we have inequality, graphical solution, interval notation solution. Sometimes you'll be asked to solve what are called combined inequalities. Combined inequalities are simply just stating that x is going to lie between two numbers. So it's almost as if you have three parts to an equation, where before you only had two sides. Here we're going to have three sides. Usually x will be in the middle, and we want to keep x in the middle. So what we want to do is try to isolate that x that's in the middle by getting rid of all of the other things that are attached to it. So in this case, I'm going to add 2 to start with. So when we add 2, we're going to get negative 3 is less than 3x, which is less than 3. Then we're going to divide everything by 3. So we're going to divide by 3 to all three parts. So that gives me negative 1 is less than x, since those cancel, which is less than 1. So this is our inequality of which we solved for. Once you have the inequality solution, it's easy to find the graphical solution. So for this one, we're going to do the graph over here. The graph is going to be anywhere from negative 1 to 1. So we'll shade all of the area in between negative 1 to 1. You could also see it in this way, that x is less than 1. Definitely x is less than 1. But also, x is greater than negative 1. You can see that down here. X is greater than negative 1. We want to show our endpoints as not being included. For the interval notation is simply from negative 1 to 1. So our interval notation would look just like it does in the graph, as being from negative 1 to 1. Two more examples. Two more examples here. Like we discussed with the fractions earlier, we always want to get rid of the denominators. Since we have three parts to this equation, whatever we do to one part, we have to do to all three parts. So if we want to get rid of the 2 in the middle, we're obviously going to multiply by 2 to get rid of that. But we're going to have to multiply by 2 to all three parts in order to keep this a true statement. So that's going to give me negative 1 times 2 is less than or equal to 3 minus 5x over 2 times 2 is less than or equal to 9 times 2. So that gives me negative 2 is less than or equal to 3 minus 5x is less than or equal to 18. Now when I subtract 3, I got to do it to all three parts. So that gives me negative 5 is less than or equal to negative 5x, which is less than or equal to 15. My last step is now to divide by the coefficient, which is negative 5. When I divide by negative 5, that gives me x. That's what I want in the middle. I'll have 1 on the left and negative 3 on the right. But did you notice what we did? Right here, we divided by a negative symbol. And when you divide by a negative symbol, remember, we have to switch the sign. So these both are going to get switched to the opposite direction. So when we go through and we do our graphical solution, we're going to show negative 3 and 1 and look at them individually. This one says x is greater than or equal to -3. So here's -3, and x is greater than or equal to it. On this side, if I cover up this is saying x is less than or equal to 1. So up here, x is less than or equal to 1. So we're going to shade everything less than. So this actually is saying x is in between these two numbers. Now, generally speaking, most people will reverse these so the negative is on the left and the positive is on the right. So if you took this whole inequality and you literally turned it around, it would say the same thing as -3 and 1, but then we also have to switch these signs around to the other direction. So these two statements actually say the same thing. This one is a lot more clear in the graph since you have the smaller number on the left-hand side. So it is okay to reverse this inequality by moving all the numbers and the signs in the opposite direction, which is what we did over here. For the interval notation, I would simply say x can be any number from -3 to 1. So here's the graph, and here's the interval notation. One more problem. Again, we've got lots of fractions and 3 parts. You see all 3 parts to this inequality. So in order to get rid of all of these denominators, we're going to need to multiply all 3 parts by the common denominator. In this case, that would be 12. So we're going to multiply 12 to all 3 parts. So that's going to give me 1/2 times 12, x plus 1/3 times 12 is less than 3/4 times 12, and we're going to reduce. 12/2 reduces to 6, 12/3 reduces to 4, 12/4 reduces to 3. So that becomes 1 times 6, 4 times x plus 1, 3 times 3. So let's distribute. Let's subtract the 4. Let's divide out the coefficient. 2/4 reduces to 1/2. So x lies in between 1/2 and 5/4. In a graphical form, 1/2 and 5/4 are located in between 0 to 1 and 1 to 2. I would say x on this side, x is greater than 1/2. So we'll shade to the right. Over here it says x is less than 5/4. So we would shade everywhere to the left of 5/4. So in other words, x lies in between the small number and this big number. We will not include the endpoints, so my interval notation is from 1/2 to 5/4.